Hey guys, so in this video we'll be going over linear inequalities in one variable. So let's start by reviewing our inequality symbols. This is our less than symbol, the greater than symbol, the less than or equal to symbol, and the greater than or equal to symbol. Make sure you're comfortable with which symbol represents which. So a linear inequality will be similar to a linear equation. And here's an example of an equation and an example of an inequality. So an equation states that two expressions are equal. And an inequality, however, states that two expressions are not necessarily equal, but one can be less than, or greater than, etc. So let's define what a linear inequality is. A linear inequality in one variable can be written in the form ax plus b less than c, ax plus b is less than or equal to c, ax plus b is greater than c, or ax plus b is greater than or equal to c, where a, b, and c are real numbers and a is not equal to 0. And just like equations, we can also solve inequalities. We find solutions to the variable that make the inequality true. Alright, so let's consider this example. We can start with x is greater than 1. Now, there are many values we can have as a solution for x, like 2, 3, 3.5, 3.7, 10, 12, basically a lot. But of course we don't want to list every solution for x. So the solution to a linear inequality can be represented in one of three ways. The first being on a graph, like a number line. The second way in set notation, and we'll talk about what this is. And the third way in interval notation, and we'll also talk about what that is. Okay, so let's start with representing our solution on a graph. We draw out a number line and then plot solutions for x that make the inequality true. These points will all work as a solution for x. Even 1.000001. However, we cannot include 1 since 1 greater than 1 is not true. We will have to place an open circle at 1 and shade everything to the right. Also, make sure to include this arrowhead at the end. And now this is the solution represented on a graph. Also note that for the greater than and less than symbol, we use an open circle. And for the greater than or equal to and less than or equal to symbol, we use a closed circle. Okay, so now to represent the solution in set notation. All this is representing the solution in curly braces. First, we write the variable x, which is read as the set of all values of x. Then this line is read as such that. And then we just write the inequality solved for x, which reads x is greater than 1. And now to represent the solution in interval notation, it will help to look at the graph. Interval notation will look something like this. Two numbers enclosed in parentheses or brackets, or sometimes both. The numbers we place inside are the minimum and maximum values of our solution. So looking at the graph from left to right, our minimum is at 1, but not including 1. Because it doesn't include 1, we use parentheses, which will always be used for open circles. Now to find our maximum solution. So this arrow means that it continues to positive infinity. So our max is actually at positive infinity. Since infinity is not an actual number, we just use parentheses. That's because infinity means that the value gets increasingly bigger without bound. So just always use parentheses next to the infinity symbol. So this is our answer in interval notation. Okay, let's try another example. We wish to graph the inequality and express the solution in both set and interval notation. We have t is less than or equal to 7. And now let's graph our solution by drawing a number line. So all of these points will be solutions for our variable t because they make the inequality true if I plug it in. 7 also works. If we plug this value in for t, we get 7 is less than or equal to 7, which is a true statement. Now we place a closed circle at 7 and we shade everything to the left. Okay, so now for set notation, we have the set of all values of t such that t is less than or equal to 7. And for interval notation, we need to write out our minimum and maximum solution. So let's look at our graph. So what's our minimum? Again, the arrowhead means it goes infinitely in this direction, so towards negative infinity. Therefore, our minimum is negative infinity, and we use parentheses for the infinity symbols. Then the maximum is at 7. And since it includes 7, we use a bracket, which will always be used for closed circles. So we usually have to solve an inequality first before expressing our solutions on a graph in set notation or interval notation. Let's go over some properties we use for inequalities, and these will be similar to the properties we use for equations. So we let a, b, and c be expressions that represent real numbers. If we have an inequality like a less than b, which could also be written as a greater than b, or a less than or equal to b, or a is greater than or equal to b, but we'll write this as a less than b for now, then a plus c is also less than b plus c, meaning we can add the same number to both sides of the inequality and it still be equivalent. So let's check this with an example. We have 5 is less than 8, which is a true statement. Now let's add 2 to both sides of the inequality. We have 5 plus 2 is less than 8 plus 2. This simplifies to 7 is less than 10, which is still true. The next property tells us that if a is less than b, then a minus c is also less than b minus c, meaning we can subtract the same number to both sides of the inequality and it still be equivalent. These properties are known as the addition property of inequality and the subtraction property of inequality. We're also going to have a multiplication and division property for inequalities, but we're going to need to be careful with these. So let's consider the following example. If we have 5 is less than 8, which is a true statement, let's try multiplying both sides by 2. We have 5 times 2 is less than 8 times 2, which simplifies to 10 is less than 16, which is still true. So this works. But now let's try multiplying both sides by negative 2. We have 5 times negative 2 is less than 8 times negative 2. Simplifying gives us negative 10 is less than negative 16, but this is not true. Negative 10 is not less than negative 16. So in order to fix this, we just need to reverse the inequality symbol. Now the inequality is true. And we'll have to take this into consideration for both the multiplication and division properties. So if we have A is less than B, and if C is positive, then A times C is also less than B times C. But if we have A is less than B and C is negative, then A times C is greater than B times C. You will need to reverse the inequality symbol whenever you're multiplying both sides by a negative. This will also be true for the next property. So if A is less than B and C is positive, then A divided by C is also less than B divided by C. But if we have A is less than B and C is negative, then A divided by C is greater than B divided by C. Again, you will have to reverse the inequality symbol whenever you're dividing both sides by a negative. So you will only be flipping the inequality symbol whenever we are multiplying or dividing both sides of an inequality by a negative number. Alright, so now let's try solving inequalities using these properties. For example 3, we wish to solve the inequality and express the solution in set and interval notation. So we will need to isolate our variable x. So to get rid of this minus 8, we're going to need to add 8 to both sides of the inequality using our addition property. So adding 8 to both sides, we can cancel out the minus 8 plus 8 on the left, and we're left with x is greater than or equal to negative 5 plus 8, which is 3. Now our variable is isolated and solved for x, and we can express the solution on a graph. So we will place a closed circle at 3 and shade all values greater than 3. For set notation, we have the set of all values of x such that x is greater than or equal to 3. Then for interval notation, our minimum is at 3 with a bracket, and our maximum goes to positive infinity with parentheses. Okay, so let's try another example. To isolate our variable this time, we need to get rid of the negative 5 being multiplied to x. So we will divide both sides by negative 5. Now, remember that we are dividing this inequality by a negative number, so the inequality symbol will need to be reversed. Simplifying, we get x is greater than 20 divided by negative 5, which is negative 4. And now we have our variable isolated. So to graph this, we place an open circle at negative 4, and we shade everything that is greater than negative 4. For our set notation, we have the set of all values of x such that x is greater than negative 4. And for interval notation, our minimum is at negative 4, and we use parentheses since it's an open circle. And our maximum goes to positive infinity, and we use parentheses. Okay, so let's move on to a more involved example. We solve this inequality the same way we solve equations. We first need to simplify both sides of the inequality. So let's distribute the 4 on the left side and the 2 on the right side. Then we can combine like terms. Next, we have to get our variable on one side of the inequality. We can subtract both sides by 2x, cancel out the 2x minus 2x on the right, and then we can get rid of this 31 by subtracting both sides by 31. Cancel out the 31 minus 31 on the left, and then 6 minus 31 is negative 25. Now we can get rid of this negative 10 by dividing both sides by negative 10. Remember, you are dividing by a negative number So we need to reverse the inequality symbol in the next step. This simplifies to x is greater than, and then reduce the fraction on the right, 5/2. Now our variable is isolated. So let's graph this. 5/2 is the same as 2.5. So place an open circle here and shade everything greater than 5/2. For set notation, we have the set of all values of x such that x is greater than 5/2. And then for interval notation, we have a minimum at but not including 5/2. So we use parentheses. And then a maximum at positive infinity, and we also use parentheses.